Right. Shall we start? Good evening, Namai. Right. Today class only for the English medium students. And from today, we will take 2 days per week to discuss Unit 3 again. Right. Unit 3 is chemical calculation. So Unit 1 is at atomic structure. Unit 2 is chemical bonds. And Unit 3 is chemical calculations. So most of students recently joined with our classes and they can miss the Unit 3. So according to the request done by most of the students, so I started Unit 3 lesson again. So you have 2 days, Unit 3 discussion sessions. The one is Wednesday 8 to 10 and the second session Thursday 8 to 10. Right? Today one is 8 to 10. So I little bit late to start today's sessions. It's okay. So I'll stop the class at 10 o'clock and we will continue tomorrow as the second session of the chemical calculations. Another thing, I hope to cover whole lesson within the few weeks because we should move to the new part. And here we discuss basically main theory points related with the calculations. Main theory points, especially redox, right? You may heard that term redox, how we balance the redox reactions and what are the changes take place and titrations part, calculations related with the back titrations, precipitations, when we have precipitate, how we get the initial mass of the compound in the mixture and impure samples, pure samples, STP calculations and density related calculations. Additional to these points, we will discuss empirical formula and the molecular formula. Right, okay. Shall we start? So I'll start with the oxidation number because that part is a major part, main part in our Unit 3 session. So oxidation number, you can write down, take a writing book. I'm not taking time to write down the notes, right? I always telling you that you can make some short notes because this is the parallel class, right? Write the topic, we will, yes, topic, write the topic oxidation now. Oxidation now. Major part of the lesson. Oxidation number. Then write down the simple meaning of the oxidation. Oxidation number, simple meaning. Oxidation number is used. Oxidation number is used to determine the number of electrons, transfer between atoms or ions. Atoms or ions in compound and molecules. In compound and molecules. The separate line. The oxidation number describes the loss or gain of electrons, from an atom in a chemical bond. Right, look at the board. Oxidation number. The oxidation number is the number of electron transfer between atoms or ions. For example, when I take sodium, sodium atomic number is 11. When you write in electron configuration, it has 281. To occupy stable electron configuration, there is 1 electron excess in sodium. So sodium should remove its outermost electron to make this stable configuration. So simply, sodium remove outermost electron, and it can be written in the product side. Number of protons initially, same as the atomic number, that is plus 11. When there's no charge, we can take as a number of electrons same as number of protons, but charge is minus. So overall charge plus 11 minus 11 is 0. After removing electron, now configuration is two-way. But number of proton does not change because the protons are inside the nucleus. We can't remove the protons from the nucleus. Always removing electrons from the outermost shells. And we can add electron to the outermost shell. So number of protons are plus 11. Electrons are minus 10. So here charge is plus 1. Charge is plus 1. So this plus 1, we can write here. The simple meaning of sodium plus is sodium plus has 1 excess proton. 1 excess proton. So when element sodium turns to sodium plus, it has removed only 1 electron. So number of electron transfer in between sodium and sodium plus is 1. The number of electron transfer here from sodium to sodium plus is 1. So number of electron transfer in between atoms and the molecules or ions, that is oxidation number. So the oxidation number here is the same as charge, that is plus 1. Oxidation number here equals to charge, that is plus 1. That is plus 1. In another way, number of electron transfer here is 1. Therefore, oxidation number of the sodium is 1. Always sodium is a metal. Therefore, it removes electrons. Never take the electron. Right? Because the sodium is metal. They have metallic lattice. Right? The all metallic ions occupy in sea of electrons. Sea of electrons. So we say that the sodium, not only sodium, all metals remove electrons. After removing electrons, they take, right? They take plus charge. So number of electrons removed here is 1. Therefore, oxidation number of the sodium is plus 1. It's same as charge of the sodium. So number of electron transfer during element sodium and sodium plus is 1. Therefore, oxidation number is 1. When I take one more example, like magnesium. Magnesium is a 12th element. It has 282. 282. To occupy this stable configuration by magnesium, it should remove outermost 2 electrons instead of gaining 6 electrons. Magnesium is easy to remove the outermost 2 electrons. So after removing outermost 2 electrons, now we have magnesium. Same theory apply here to number of protons plus 12, number of electrons minus 12. So charge is 0. There is no charge. So here oxidation number is 0. Oxidation number at the elemental state is 0. Oxidation number at the elemental state is 0. Here also 0. Now the configuration is 2A. Number of protons still not changed, that is plus 12. But electron change to 2 plus 8, 10, minus 10. So now charge is plus 2, here 2. So this is the oxidation number of the magnesium after removing 2 electrons. Right? After removing 2 electrons, magnesium takes plus 2. The plus 2 charge we call oxidation number. Or in other way, the number of electron transfer in between magnesium and magnesium 2 plus is 2. Therefore, oxidation number of the mechanism is. So, number of electron transfer between elements and the ion, right, called oxidation number. Right, please note down. Don't take too much time to note down theory points. Right. Done. මම පුතාලට හරියම බේසික් පොයින්ට් එකේ ඉඳන් කියලා දෙන්න. right ස්පීඩ් එකේ ඉගෙන ගන්න බෑ. හරියට තියරි ටික ඔලුවට ගන්න. ඊට පස්සේ ඔයාලට ඕනම කැල්කියුලේෂන් එකක් සිම්ප්ලිෆයි කරන්න පුළුවන්. මේ තියෙන බේසික් ඔක්සිඩේෂන් ස්ටේට් එකෙන් මෙතනින් පටන් ගත්ත තැන ඉඳන් රෙඩොක්ස් කැල්කියුලේෂන්ස් වලට වෙනකන් එක දිගට යනවා. right ඔයාලා අවශ්‍ය දේවල් නෝට් ඩවුන් කරගෙන හරි පිළිවෙලට යන්න. right then when I take compounds, right? Or yes, we take compounds or molecules. Molecules can be categorized into two groups. Homoatomic molecules. Homoatomic molecules. Right? Homoatomic molecules. And the next one is heteroatomic molecules. Heteroatomic molecules. For example, we can take H2, N2, homoatomic, right? Same metals. Same metals. We can take O2. When we take such molecules, they have no electronegativity difference. What is meant by electronegativity? The electronegativity is the ability to attract the electron from the bond. For example, if I take HF bond, fluorine has more ability to attract the bonded electron by itself. Because of that, even this one is the covalent bond. The covalent bond is the bond formed by two atoms sharing electrons. The shared electrons given by both atoms. So, hydrogen has given 1 electron. Fluorine also has given 1 electron. That is the bond. That is the bond. But even they form a bond by giving one electron, fluorine has excess ability to attract the bonded electrons. So fluorine attract the bonded electrons like that. Because of that, the total electron cloud distributed among the two atoms get accumulate around the one atom. Therefore, total electron density around the fluorine get increased by little bit, not completely. To top electron density dependent. Because of that, we assign charges as a partial charges. The element which has great ability to attract the bonded electron, we give delta minus. The meaning of delta mean delta, the small amount, little amount. The same amount of the electron density around the hydrogen get decreased. Therefore, we assign delta plus. In other way, the total positivity around the hydrogen get increased. Total positivity. Fluorine increases its total electronegativity. The electron density around the fluorine. So such one are polar bond. Polar bond. So heteroatomic molecules formed by polar bond. So we can say polar molecule. Different atoms, the atoms which has different electronegativity, share their electrons and they make a bond. Homoatomic molecules are non-polar molecules. Non-polar molecules, they have no electronegativity difference. Both oxygen atoms have same ability to attract the bonded electron. Both hydrogen in H2 have same ability to attract the bonded electron. Got it? So we can't assign the positive or negative charges for homoatomic molecule. In such cases, we consider their oxidation number as 0. So oxidation number on each atom is C. This one also have 0 oxidation. Right? Oxidation number is 0. The simple no electronegativity difference. No electronegativity difference. Therefore, oxidation number is C. Oxidation number is C. Oxidation number is C. But when you take heteroatomic molecules like HF, HO, Na, so such one has different electronegativity values. Here 2.1, here 4.0. Here 2.1, 3.5. Here 3.0, here 2.1. The atom which has more electronegativity, we assign negative. Here, positive. Temporarily, we assume this covalent bond act as ionic bond. Actually, it not happen. But temporarily, for a small time, we assume that the covalent bond act as ionic bond. That's why we can assign plus and minus charges. Minus charge given for the element which has greater electronegativity, plus 1 given for the lower electronegativity for a one bond. For a one bond. Here minus 1. Here minus 1. Like so sign minus 1 for highest electronegativity element. For a bond. For a bond. For a bond. Assign plus 4 lower electronegative element for a bond. This is the simple rule to apply to get the oxidation number. So the sum of the assigned charges we call oxidation number. Right? So on the same point here, for the same point, if I take water molecule here, it has two OH bond. Hydrogen has 2.1, oxygen has 3.5. Because of this bond, hydrogen takes +1, oxygen takes -1. Because of this bond, hydrogen takes +1, oxygen takes -1. So total charge around oxygen is -1, -2. So this one we call oxidation number of oxygen in water. Of oxygen in water. So +1, one oxygen, one hydrogen in water takes +1. So this is the oxidation number of hydrogen in water. Oxidation number of hydrogen in water. So this is the simple theory we should apply. There is a special point. Look at the board. We have no time to waste, guys. Fluorine and oxygen. Look at the board. The fluorine 4.0, oxygen is 3.5. Fluorine 4.0, oxygen 3.5. So due to this bond, fluorine takes -1, oxygen takes +1. Because of this bond, fluorine takes -1, oxygen takes +1. So overall charge around oxygen here is +2. Remember that. There is only one example which has +2 oxidation state on the oxygen. That is OF2. That is OF2. We have only one case with the +2 oxidation state on oxygen because oxygen is comparatively higher electronegative element. Electronegativity of the oxygen is get less only for the fluorine. When oxygen form a bond with fluorine, it forms plus charges. Oxidation number of the oxygen takes +2 when it form a bond with fluorine. That is a special point you should remember because in some exam papers, they have indicated such questions with that point. Okay, I think you got clear understand. I'll give the few minutes to note down this theory. After that, we will continue with the next few points. Right. Done? Enough. No. Right. Then there's another point you should remember when you're finding oxidation number of the element, especially in the molecule. For example, potassium permanganate, KMnO4, the oxidation state of the manganese. How you get the oxidation state of manganese? You should know. Right. Note down this table. Right. This is really simple table. And there's last theory point. This one table. Right. Here, Putana. Element. Oxidation number. An example. Right. First one I take. First group element. Group 1 element. 1A group element. The oxidation number is 0. Sorry, plus 1. Plus 1. Oxidation number equals to right. My little princess, she just turned 2.5. Right. She also likes to teach. Right. Look at the board. Group 1 element. The oxidation number is plus 1. Example. Elements belongs to group 1 of lithium, sodium, potassium, rubidium, cesium. When they form compounds, always they have plus 1 oxidation number. Group 2 elements. Oxidation number equals to plus 2. Elements beryllium, magnesium, calcium, strontium, vanadium. Radioactive elements do not form compounds, chemical compounds. They just turn from one nuclear to the other. So after that, third group elements. Their oxidation number is plus 3. Boron, aluminium, gallium, indium, thallium. Addition to plus 3, these 3 elements form plus 1. Right? Most of the compounds we take in our syllabus with the boron and aluminium. Therefore, you no need to worry about gallium, indium, and thallium. And then elemental state. Right? Elements in elemental state, they have 0 oxidation state. For example, sodium. Right? Magnesium. In elemental states, they are in compounds. They form plus, these elements as plus 2 in the compounds. So sodium, magnesium, right? H2, N2, P4, SA. So P4 is this one. P4. Each phosphorus make a covalent bond with another one. Therefore, that is homoatomic molecule. Therefore, the oxidation state is 0. SA, crown shape. It has crown shape like this. SA. Its sulfur has 2 lone pair. So there is covalent bonds in between same atoms. Therefore, oxidation number is 0. 0. So after that, oxygen has few oxidation states, right? Starting from -2, -1, -1, 0, 0, +1, and +2, +1 and +2. -2, all oxides except OF2. Right? You already know that. There is positive +2 charge on oxygen when it forms OF2. Other than OF2, all oxide has +2 oxidations. +1. So this one we call oxide. +1 we call peroxide. -1. -1 called peroxide. -1 and 0 we call superoxide. Superoxide. Peroxides formed by elements from first group elements, hydrogen, except lithium, other all form peroxides. Hydrogen peroxide. Except lithium, sodium peroxide, potassium peroxide, rubidium peroxide, cesium peroxide. Addition to that, from the second group elements, only barium, right, the last element before, right, radium, also form peroxide. So peroxide is O2 2 minus, right? O2 2 minus, that is peroxide. 2 oxygen atoms combined with covalent bond, and each oxygen has 7 electrons. Therefore, 1 minus 1 charge on each oxygen. So that's why we take -1 peroxide. O2 2 minus. O2 2 minus. Then superoxide formed by potassium, rubidium, and cesium. Right? Potassium, rubidium, and cesium. KO2, RbO2, CSO2. These are superoxide. They have -1 and 0 charge. For example, when I take peroxide, here, 1 oxygen has exactly 6 electrons, including 1 single electron. The other oxygen has excess 1 electron, that's why -1 charge. -1 charge. So 0 is on O2, +1 on O3, called ozone. Ozone, +2 on OF2. OF2. Right, I'll draw the molecule of O3 here. So this is the formula of O3. Central oxygen has +1 charge. So the oxidation state here is oxidation number. Oxidation state here is +1, +1, +1, +1. Right? So addition to this, I have to explain halides and hydride. So before that, please note down these points. We should know these points to continue this part of the lesson. Please note down. Don't take much time. If you have any questions, please send WhatsApp. Come on, guys, hurry up. Right. Done. One of you guys can ask why other element than potassium, rubidium, cesium do not form superoxide. Right. The main reason is because of the small size on hydrogen, lithium, sodium, they can't keep negatively charged electron. So they can't form the stable compounds with O2 minus. O2 minus. O2 minus. That's why they do not form superoxides. Done. Okay. Right. You can ask any questions, Patala. You can ask. Right. Okay. Then shall I erase? Next, hydrogen. Hydrogen has 3 oxidation numbers. Hydrogen. -1, 0, and +1. -1, 0, and +1. -1 oxidation number of hydrogen shown when it forms ionic bonds with metals. Right? Hydride, metallic hydride. Metallic hydride. Because I explained that to you, there's no negative charges with the metals. Metals always form plus. Therefore, when sodium combined with hydrogen, sodium always take +1 because it belongs to first group. Therefore, hydrogen should take -1. -1. Therefore, hydrogen takes -1 oxidation state when it forms metallic hydride, right? Hydride with metals. The second example, magnesium hydride. Here +2, -1. Zero oxidation state on H2, right? H2 +1 oxidation state, hydride with non-metals. So H2O can be taken as hydride of oxygen. In other way, oxide of hydrogen. Hydride of oxygen or oxide of hydrogen. So hydrogen takes +1 because oxygen is non-metal. And HF. Fluorine is non-metal. Therefore, hydrogen takes +1. So at that level, we consider the electronegativity. Right? CH4. Hydrogen has hydrogen has 2.1, carbon has 2.5. Therefore, hydrogen has lesser oxidation, lesser electronegativity than carbon. Lesser electronegativity than carbon. Therefore, it takes plus. And finally, We have halogens, right? Halogens. Except I'll take fluorine, bromine, iodine. Second. I'll take second. Fluorine, -1 and 0. There's no positive electron, positive oxidation state of fluorine. Fluorine has -1 and 0. Because of the highest electronegativity value, always fluorine take -1 when we combine with other element. HF, NF, MgF2, OF2. Because of the highest electronegativity, fluorine always takes -1 with the compounds. 0 can be taken when it form F2. Other than fluorine, halides or halogens, we call fluorine, bromine, iodine. They have the large range of the oxidation number. Chlorine, bromine, iodine. Chlorine, bromine, iodine has large range of the oxidation number, starting from -1 to +7. -1, 0, +1, +3, +5, and +7. -1, 0, +1, +3, +5, +7. So -1, same as fluoride, HCl, HBr, HI can be taken. Right? Can be taken. Or you can take NF, NCl, NBr, at that place. 0, Cl2 gas, Br2 liquid, I2 solid. You should remember the physical states too, okay? +1, can you see that? I'll use other side to write the examples for +1. +1, HOCl, HOBr, HOI. +3, HClO2, HBrO2, HiO2. +5, HClO3, HBrO3, HiO3. +7, that is highest one, HClO4, HBrO4, HiO4. These are the oxidation states, oxidation numbers relevant to fluorine, bromine, iodine, hydrogen, oxygen, first group elements, right? Second group elements, third group elements, and oxygen, right? So please note down these two, right? I'll explain how to get the oxidation numbers of the element in the compound by taking the formula method and Lewis structure method as the last part of the today's lesson. Note down. right complete ඔයාලට පොඩක් boring වගේ ඇති පුතේ boring කියන්නේ මෙහෙමයි we have a limited time නේ පැය දෙකක class එකක් මගේ මේ වෙනකොට theory classes වල unit 3 completely ඉවරයි completely ම කියන්න බෑ basic theory ටික අපි ඉවරයි තව sums ගොඩ කරන්න තියෙනවා මේ වගේ night sessions අරගෙන තමයි අපි complicated calculations practice කරන්නේ හැබැයි මේ වෙනකොට theory ටික complete then අපි next month March will start කරන්නේ unit 4 gas law කියන lesson එක 1 2 3 හරි පිළිවෙලට කරගෙන ආව class එකක් daily review papers YCOB papers ලියලා telegram group එකේ daily questions අපි දානවා ඒ questions වලට අපේ දරුවෝ ලියලා ඒගොල්ලෝ ලස්සනට ඒක manage කරනවා plus මේ වෙනකොට paper classes start කරලා තියෙන්නේ papers 10ක් full papers 10ක් MCQ structure design ඔය කියන තුනම include කරපු full papers 10ක් මේ වෙනකොට අපේ paper classes වල ඉවරයි. ඒ වලට discuss කරලා ඉවරයි. ඉතින් ඒක නිසා අපි සෑහෙන plan කරලා කරන වැඩක් full paper එකක් කියන පුතේ first term test එකට එන්නේ unit 1 2 3 වලින්. ඒතර unit 1 2 3 වලින් ලියන්න පුළුවන් විදිහට අපි paper එක හදලා තියෙන්නේ. paper class එක අපි start කරේ last year December වල. එතකොට හිතලා බලන්න ඔයගොල්ලෝ අපේ classes වලට physically ඇවිල්ලා නැත්නම් online join වෙලා මේ වෙනකොට අපි first 3 lessons complete කරලා මම හිතන්නේ ප්‍රශ්න 400කට එහා අපි කරලා ඉති class එකක් ඇතුලේ YCOB papers මොනවාද අපි review papers එතකොට telegram group එකේ දැන් යනවා ප්‍රශ්න 250කට ආසන්නයි දැන් ප්‍රශ්න 250ක් ඔව් එතකොට calculation unit 3 එකේ අපි sums කරලා තියෙනවා මම හිතන්නේ 350ක් විතර right past paper class එක ඒක අපි free කරන class එකක් Sunday night අපි කරනවා 2000 වල ඉඳන් past papers එක දෙකට continue වෙනවා දවස් 7ෙම chemistry class එකත් එක්ක සම්බන්ධ වුණොත් ඒ chemistry එක්කම ඉස්සරහට ලොකු වැඩ කොටසක් කියන්නේ exam එක term test එකක් නැත්නම් A level exam එකේදී ඒ වෙනුවෙන් දවස් 2-3 නිදි මරාගෙන පාඩම් කරන්න අනිත් classes යන්නේ නැතුව පාඩම් කරන්න අවශ්‍ය class එකක් නෙවෙයි අපේ ක්ලාස් එකේ හැම දවසකම ළමෙක්ව ලස්සනට ට්‍රේන් කරනවා අර බරපතලක් නැතුව සබ්ජෙක්ට් එක ගැන ලොකුවට අමාරුවක් නැතුව හැමදේම ඕවරෝල් මතක් කර තීරි පොයින්ට් එක හරි සූක්ෂම වෙන රයිට් මේ මෙතන තියෙන සමහර තීරි අපි කතා කරන්නේ inorganic lessons එක ඒ කියන්නේ inorganic lessons කියලා කියන්නේ පොතේ 6 lesson එක අපි lesson 3 එකේ ඉඳන් අපි අතර මේක 2 වල කතා කරා 2 වල කතා කරපු එක අපි 3rd එකෙත් කතා කරන එක ඇහිලා ළමයට පුරුදු වෙන නිසා. එතකොට එයාට එතනින් එහාට calculations හරි ලස්සනට continue කරන්න පුළුවන්. අපි බය නැතුව school term test papers right හැම province එකම term test papers කතා කරනවා. past papers මේ වෙනකොට අපි start කරලා තියෙනවා. බය නැතුව අපිට එහෙම කතා කරන්න පුළුවන්. අපි theory class එකේ ඇතුලේ හැම theory point එකක්ම අඩුවක් නැතුව complete කරන නිසා. right ඉතින් ඒක නිසා අලුතෙන් මේක සම්බන්ධ වෙන දුර පුතාලා ඔයාලට පුළුවන් 4th lesson එකත් එක්ක ඉස්සරහට continue කරන්න unit 2 එකේ අපි එක seminar එකක් කරා එතකොට තව seminar ඉස්සරහට ඕගොල්ලන්ට හැම month end එකේම seminar set වෙනවා ඒ seminar වලින් ඕගොල්ලන්ට පුළුවන් මොනවාද අමතක පිට සහ හරියට set pitch නැති theory points ටික cover කරගන්න ඊට අමතරව අපේ recordings තියෙනවා unit 2 unit 1 වල හරියට කරගත්තේ නැති දුර පුතාලට ඒ recordings plus theory note ඒකේදී කරපු papers YCOB papers plus review papers ඒ ඔක්කොම papers ඔයාලට ගන්න පුළුවන් right ඊට අමතරව unit 3 එක ටිකක් අර deep lesson එකක් නිසා fast track එකක් වගේ English medium Sinhala medium classes වලට separate English medium classes වලට තියෙන Wednesday and Thursday Sinhala medium දාලා තියෙනවා Monday and Tuesday ඔය විදිහට තමයි දාලා තියෙන්නේ Friday තියෙන අපේ organic 2025 අක්කලා ඊළට organic session එක continue වෙනවා ඉතින් ඔහොම තමයි අපි set වෙලා තියෙන්නේ දවස් 7ෙම අපි online මේ විදිහට classes කරනවා physical ඊට අමතරව classes කරනවා ඉතින් සතිය දවස් 7ෙම chemistry ම තමයි බරක් නැතුව ආසාවෙන් ඉගෙන ගන්න දුල පුතලට හරි ෂෝක් එකට right මේක කරගන්න පුළුවන් ඉතින් බරක් විදිහට හිතන්න එපා ද මේ පැය දෙක ඇතුළත ඔයගොල්ලෝ ගන්න පුළුවන් theory points ටික ඔක්කොම ගන්න right මේක කරන්න කොහොමද මේක කරන්න කොහොමද මේ වගේ එකක් આવුත් ආයකට apply කරන්න කොහොමද? ඒකේ full marks ගන්න කොහොමද? ඒක හැමදේම පුතාලට මේ limited time period එකේදී කියලා දෙනවා. ඉතින් ඒකට බය නැතුව right ඉස්සරහට continue වෙන්න පුළුවන්. ඉතින් ළමයින්ම recommend කරන class එකක් මේක පුතාලට බලන්න පුළුවන්. අයියලක් කළා රයිට් කියන කතාවක් තමයි ටීචර්ගේ නෝට් එකයි ටීචර් උගන්වන ප්‍රමාණය ගත්තොත් ක්ලාසස් 10කට ගිහිල්ලවත් කම්ප්ලීට් කරගන්න බෑ රයිට් ඉතින් එච්චර වැඩ ගොඩක් කරන සුපිරි ක්ලාස් එකක් අපේ ක්ලාස් එක කැමති අයට සම්බන්ධ වෙන්න පුළුවන් දීලා තියෙන ලින්ක්ස් වලින් ඒ අදාළ groups වලට join වෙන්න පුළුවන් ඊට අමතරව පුතේ මේ දවස්වල රයිට් මම අලුතෙන් ක්ලාසස් පටන් ගෙන තියෙනවා කඩවත සයන්ස් ඉමේජ් රයිට් කඩවත සයන්ස් ඉමේජ් ආයතනයේ මම මේ වෙනකොට ෆිසිකල් ක්ලාසස් සම්බන්ධ වෙලා ක්ලාසස් පටන් ගන්න තියෙනවා. ඉතින් මේ වෙනකොට ඇත්තටම මේ ගම්පහ විශේෂයෙන්ම ගම්පහ ලොකු ස්පේස් එකක් තියෙනවා. කෙමිස්ට්‍රි ඉංග්‍රීසි මීඩියම් ක්ලාස් එකක් නෑ නේද කියලා ඔන්න ඕගොල්ලන්ට තියෙන හොඳ කෙමිස්ට්‍රි ඉංග්‍රීසි මීඩියම් ක්ලාස් එකක්. මම හිතන්නේ ගම්පහ ඉඳන් කඩවතට එච්චර ලොකු දුරක් නෑ. පොඩි දුරක් තියෙන. ඉතින් ෆ්‍රයිඩේ සිකුරාදා අපි 3:15 to 7:30 වෙනකම් පුතේ ක්ලාස් එක කන්ටිනියු වෙනවා. වැඩිපුර වැඩ කරන ක්ලාස් එකක්. ඊට අමතරව පේපර් ක්ලාස් එක සන්ඩේ ෆිසිකලි ඇවිල්ලා ලියන්න පුළුවන්. සැටර්ඩේ ඩිස්කෂන් එක වෙනවා. ඉතින් අර මගේ මුලින් ඉඳන් සම්බන්ධිච්ච දූල පුතාලට වගේම අලුතෙන් සම්බන්ධ වෙන සයන්ස් ඉමේජ් එකේ කඩවත ඉන්ස්ටිටියුට් එකත් සම්බන්ධ වෙන දූල පුතාලටත් හැමදේම අකුරක් නැර අඩුවක් නැර හැමදේම හම්බ වෙනවා. තියන්න ඕන එකම එක දේ විශ්වාසය විතරයි. රයිට් දරුවෝ ගොඩාක් ගොඩ යන පන්තියක් මගේ ක්ලාස් එක. ඒ හැම දරුවෙකුම උපරිමයෙන්ම හැමදේම දෙන ක්ලාස් එකක්. රයිට් හරිද පුතේ එතකොට ඒ අදාළ දරුවන්ටත් ඒ අදාළ ක්ලාසස් වලට සම්බන්ධ වෙන්න පුළුවන් කාට හරි නුගේකොට සැසිප් රත්මලානේ ක්ලාස් එකට එහෙම නැත්නම් නුගේ කඩවත ක්ලාස් එකට ජොයින් වෙන්න බැයි නම් ලංකාවේ ඕනම දරුවෙකුට අපේ ඔන්ලයින් ක්ලාසස් වලට සම්බන්ධ වෙන්න පුළුවන් ඔන්ලයින් ක්ලාසස් ටිකත් අපි හරියම පිළිවෙලට ෆිසිකල් ක්ලාස් එක වගේම ඔරියන්ටේෂන් එක දීලා කරගෙන යන නිසා කිසිම කෙනෙකුට ෆිසිකලි ආවත් ඔන්ලයින් ආවත් ඒකේ කිසිම ඩිෆරන්ස් එකක් නැතුව ක්ලාස් එක කරගෙන යන්න පුළුවන් හරිනේ රයිට් බෑක් ටු ලෙසන් ඊළඟ පොයින්ට් එක ලියන්න පුතේ මෙන්න මෙහෙම. ඔයාලා ක්වෙස්චන්ස් අහන්න පුතේ ඔයාලට තේරෙන දේවල් රයිට් අපහැදිලි දැන් තේරෙන දේවල් නේ අපහැදිලි දැන් රයිට් ක්ලියර් නේද දැන් ඔයාලට මගෙන් අහන්න පුළුවන් රයිට් අපේ ටී-ෂර්ට් එක ලොන්ච් කරේ අපි අද මේ කට්ටිය අපේ 2025 කොළඹ මහනාමේ අයියා කෙනෙක් විකාශ් එයත් එක්කම යාගේ යාළුවා සොනාක් වදින තමයි අපේ ටී-ෂර්ට් එක ඩිසයින් කරේ ක්ලාසික ටී-ෂර්ට් එක ඒකලම තමයි print කරේ ඉතින් ඒක මහන්සිලා කරපු වැඩක් රයිට් අද මම මේ ෆස්ට් ටයිම් මේ ටී-ෂර්ට් එක අඳින්නේ දැන් ඔයාලට දිගටම මේ ටී-ෂර්ට් එක අවශ්‍ය දරුවන්ට ගන්න පුළුවන් අපි ගොඩක් කට්ටියක ඕඩර් කරලා තිබ්බා ඒගොල්ලෝ කියව මේ සතිය ඇතුළත ගන්න පුළුවන් ඊට අමතරව අලුතෙන් කාට හරි ඕන නම් එයාලටත් ගන්න පුළුවන් right පුතේ ලියා ගන්න next point basic rules that apply in the determination of the oxidation number in the determination of the oxidation number write down the first rule the sum of the oxidation numbers of all the atoms In N compound, is equal to 0. Is equal to 0. Second point, the sum of the oxidation numbers, of all the atoms, in an ion, equals to its charge. Okay. Right. Look at the board. We have two methods, right? I separate them as formula methods and structure method. Formula method and structure method. Formula method and structure method. Formula, example, sodium thiosulfate. Sodium thiosulfate. I start with the little bit little bit complicated examples, because you know how to get the oxidation number from the simple, through the simple form. Sodium thiosulfate, Na2H2O3, we call sodium thiosulfate. You need to take oxidation number of the sulfur. Right, according to formula method, look at the board. Na2H2O3, sodium is the element belongs to first group. Therefore, it has +1 as oxidation number when it forms compounds. So here +1 into 2. Because there are 2 sodium. That's why you need to multiply this by 2. +1 into 2. Plus, you need to take oxidation state of sulfur. For one sulfur, take as any variable as X, Y, Z, or any variable. There are 2 sulfur atoms. Therefore, you should take this one as 2X. +1 into 2 plus 2X plus oxygen. Oxygen here combined with sulfur. When oxygen combined with nonmetals, takes -2. So here, one oxygen has -2. There are 3 oxygen atoms. Therefore, multiply by 2. You clearly understand? Sodium belongs to first group elements. Therefore, one sodium has +1 into 2. And there are 2 sulfur atoms. One takes X because we need to take the oxidation state of sulfur. 2X plus 1 oxygen -2. There are 3 oxygen atoms. Therefore, -2 into 3. Sum of these 2, right? These 3 should be equals to 0 because this one is the compound. +1 into 2 plus 2X plus 1 oxygen -2 because this one is oxide. Sodium thiosulfate -2 for 1 oxygen. There are 3 oxygen atoms, therefore -2 into 3. So sum of these 3 equals to 0 because of this one is compound. So when you simplify this, 2X equals -6 plus 2 is -4, goes to other side +4. X will be +4/2, that is +4. There are 2 sulfur atoms with plus 2 oxidation number. But when you take the structure method, look at the board. Thiosulfate is this one. This is sodium thiosulfate. This is the Lewis structure of thiosulfate. Here negative charge thiosulfate. When there is sodium thiosulfate, there is an ionic bond between sodium plus and O-. Right? O-. Like this. Sulfur, sulfur, double. So as I explained previously, for one bond, highest electronegative element takes -1. Oxygen and sulfur. Oxygen and sulfur both belongs to 16 group. Down the group, electronegativity decreases. Down the group, electronegativity decreases. Sulfur is lower than the oxygen. Therefore, when you consider this one, there is only one bond, one right line, therefore one bond. Sulfur take +1, oxygen takes -1. Due to this bond, oxygen takes -1, sulfur takes +1. Here, double bond, two bonds. If one bond designed with +1, -1, double bonds assigned with -2, +2, -2, +2. Here, same atom, sulfur, same atom. Electronegativities are same. Therefore, we can't assign +-4. Same atoms, bonds formed by same atom. Therefore, here 0, 0. Due to this bond, +1, -1. Due to double bond, +2, -2. Due to this single bond, +1, -1. So oxidation number given by the overall charge due to bonds and the charge already exists. So central sulfur has +1, +2, +1, total as +4. Surrounding sulfur has 0. Remember that. From the formula method, we can take average value. This is the average value. Average oxidation number of the sulfur. There are 2 sulfur atoms, right? Overall here, 4 + 0 is +4. +4 divided by number of sulfur atoms gives the average value. So average oxidation number of the sulfur is +. But exactly, right? Thiosulfate has 2 oxidation states. The surrounding sulfur has 0. Central sulfur has +4. Please note down. I'll explain this point with few more examples. Please note down. Done. Right. Then I take the second example, that is sodium tetrathioate. Sodium tetrathioate. Na2S4O6. Na2S4O6. One sodium plus, there are two sodium. You need to take the oxidation state of sulfur. One take X, there are four, therefore 4X. One oxygen minus 2, there are 6. This is the compound, therefore sum will be equal to 0. So 4X equals to minus 12 plus 10 x will be 10 over 4, that is plus 5 over 2. Now you know this is the average value. Average one. To get the exact one, this is the tetrathione sulfate, tetrathione. There are 4 sulfatons linearly combined. Then this is the oxygen atom, the carbonic bond with the sodium. Right, now you know how to get it. Minus 2 plus 2, minus 1 plus 1. Same atoms, therefore 0, 0, minus 2 plus 2. Overall charge is plus 1. So oxidation state on this sulfur is plus 5, plus 5. Here same atoms, therefore 0, 0. Same atoms, 0, 0. Minus 2 plus 2, minus 2 plus 2, minus 1 plus 1, here plus 1. So now you can see there are 2 sulfur atoms with 0 oxidation states, and there are 2 sulfur atoms with plus 5 oxidation state. Right? Plus 5, plus 5, plus 2 plus 2 plus 1 plus 5, and 0 oxidation state. So how we get the average? Plus 5 plus 0 plus 0 plus 5 divided by total number of sulfur atoms. Plus 5 plus 5 plus 10. There are 4 sulfur atoms plus 10 over 4. That is 5 over 2. 5 over 2. Right, please note down this and please take the oxidation state of K-MnO4, manganese in K-MnO4. I'll give a few examples. You can take the oxidation state of manganese by taking formula method and structure method. H2SO4, third one. I'll give CO3 2 minus, fourth one Cr2 or 2 minus. As a fifth one, I'll give Cr. No, I'll give the different one, the aluminum. Aluminum. Right, this thing. Right, finish. Shall we check? I know you can take the oxidation numbers of these elements easily. KMnO4, right? KMnO4, potassium plus 1 because it belongs to first group element. Manganese take as X, oxygen minus 2 into 4, sum of these equals to 0. So X will be plus 7. When you want to draw the formula, structure, so this is the potassium. You can use this method. Or this one, right? So minus 2 plus 2. Metal has lower electronegativity, right? Metal has lower electronegativity than the non-metals. Minus 2 plus 2 plus 2 minus 1 plus 1. So overall charge is plus 7. Plus 7. When you take H2SO4, this is the sulfate, iron, and the oxygen O minus combined with hydrogen to make the covalent. Yes, minus 2 plus 2, minus 2 plus 2, minus 1 plus 1, minus 1 plus 1. Overall charge here is plus 6, plus 6. You may have two different oxidation numbers when you have more than one central atom. Here, only one central atom. That's why you have only one oxidation number. Carbonate, CO3 2 minus. So this is the structure of the carbonate ion. Minus 2 plus 2, minus 1 plus 1, minus 1 plus 1. Overall charge here is plus. Aluminate. Here, aluminate. Minus 1 plus 1, minus 2 plus 2. Here, oxidation state, here, plus 3. Aluminium should have plus 3 because it belongs to third group. And finally, dichromate, it has two central atoms. When you have two central atoms with odd number of oxygen, more than 3, 1, 3, 5, 7, odd numbers, no? So when you have two central atoms with the odd number of oxygen atoms greater than 3, take one oxygen in between two center atoms, right? Take one oxygen in between two center atoms. And Cr2O7. Then the remaining 6 oxygen atoms combine with the surrounding chlorine atoms. Minus 2 plus 2, minus 2 plus 2, minus 1 plus 1, minus 1. So overall charge here is plus 6. This one also same, minus 2 plus 2, minus 1 plus 1, minus 2 plus 2, minus 1 plus 1. Here is plus 6. So if you use formula method, Cr2O7 2 minus, you need to take the chromium. There are 2x plus minus 2 into 7. Sum of these two equals to overall charge, right? Overall charge, because this one is iron. Sum of these two, the oxidation state of the chromium plus oxidation state of sulfur, the sum will be equals to overall charge, that is minus 2. So when you simplify this, X will be plus. Right. So those are the simple theory point, and I will continue your class tomorrow at 8 p.m. with the next few part, nomenclature, very important. Before going to redox balancing reactions, we need to do the nomenclature part. With that, I'll start the redox balancing in acidic and basic medium. So little bit fast class, right? Fast, I'll do the fast because we have limited time to cover whole lesson. I'll try my best to cover Unit 3 before your first term test. I think most of the schools already had their term test. We'll see. Right, okay, guys. So thank you very much for joining today's lesson. I want your comments, right? Please give the comment related with the today's session, and we'll continue with the next few part tomorrow. Right. Thank you very much. Good night.